Welcome to SND College of Engineering and Research Center, Yeola, Department of Applied Science online lecture series. Today's online lecture series on subject Engineering Physics, Unit 1st, Interference. In previous videos, we have already seen that interference, diffraction, polarization. Today we will discuss about only numericals based on interference. In interference, we already see interference in thin film of uniform thickness, interference in thin film of wedge shape or non-uniform thickness, and applications. So let's see. First, in Newton ring experiment, the diameter of the 10th dark ring changes from 1.4 cm to 1.27 cm when a liquid is introduced between the lens and the plate. Calculate the refractive index of the liquid. So what is the problem? In Newton ring experiment, the diameter we have to find diameter is 10th dark ring changes from 1.4 cm to 1.27 cm, and we have to calculate the refractive index of the liquid. Newton ring diameter is 10, then D10 for air is equal to 1.4 cm. What is given? D10 in air is equal to 1.4 cm. Then what is the formula? D means diameter, dn air upon dn liquid is equal to under root mu. Diameter of nth dark ring is dn liquid is equal to under root 4nr lambda upon mu. For air film, refractive index is 1, then dn air is equal to 4nr lambda. For D10 for liquid, divided 2 by 1, then dn air upon dn liquid is equal to under root of mu. Therefore, mu is equal to dn air upon dn liquid, squaring on both sides, square is equal to, then dn air is 1.4 cm, then 1.4 square upon d10 is 1.27, then upon 1.27 square is equal to 1.215. then refractive index of liquid is 1.215. Let's see second problem. A plane wave of monochromatic light falls normally on uniformly thin film of oil having refractive index 1.3, which covers a glass plate of refractive index 1.5. The wavelength of the source can be varied continuously. Complete destructive interference is obtained for wavelength 5000 degree angstrom and 700 degree angstrom, and no other wavelength in between. Find the thickness of the oil layer. So what is the problem? We have plane wave of monochromatic light normally falls on the uniform thin film of oil thin film having refractive index is 1.3, and this thin film also covered with glass, and then glass refractive index is 1.5. The wavelength of source is varied continuously. Then we have to find thickness of the oil layer. So given refractive index of oil is 1.3, refractive index of glass is 1.5. For normal incidence, R is equal to 0. Then in this problem we have also known as wavelength. Lambda 1 is equal to 7000 degree angstrom is equal to 7000 into 10 raised to minus 8 centimeter. Lambda 2 is equal to 5000 degree angstrom, 5000 into 10 raised to minus 8. Then we have to find thickness. effective optical path difference to reflected rays in reflected system. Therefore delta is equal to 2 mu refractive index of oil T cos of R plus minus lambda upon 2 plus minus lambda upon 2 is equal to 2 mu oil means 2 multiply refractive index of oil T cos of R. For nth order destructive interference of lambda 1 is equal to 2 mu oil T cos of R is equal to 2n1 minus 1 lambda 1 upon 2. This is first equation. For second order 2 mu oil T cos of R is equal to 2n2 minus 1 lambda 2 upon 2. Divide equation 1 by 2. Therefore 2n1 minus 1 upon 2n2 upon 2n2 minus 1 is equal to lambda 2 upon lambda 1. Then we have already known wavelength. Lambda 2 is 5000, lambda 1 is 7000. Lambda 2 5000 divided by lambda 1 7000 is equal to 5 upon 7. Then 2n1 minus 1 is equal to 5. Therefore n1 is equal to 3 and 2n2 minus 1 is equal to 7. Therefore n2 is equal to 4. Putting n1 3 and lambda 1 is equal to 7000 degree angstrom is equal to 7000 into 10 raised to minus 8 centimeter in thickness T can be found. Then T is equal to 2n1 minus 1 multiply lambda 1 upon 2 divided by 2 mu oil cos of R. Then 2 multiply n1 is 3. 2 multiply 3 minus 1 multiply lambda 1 is 7000 into 10 raised to minus 8 divided by 2. Also divided by 2 multiply refractive index of oil is 1.3 into cos theta or theta is 0. Then answer is 6.73 into 10 raised to minus 5 centimeter. What is the answer? 6.73 into 10 raised to minus 5 centimeter is equal to 6730 degree angstrom. Let's see second example. When light is incident on a soap film refractive index is mu is equal to 1.33 at an angle sin inverse 4 upon 5 and the reflected light on examination shows dark bands. Two consecutive dark bands corresponding to wavelength 6100 degree angstrom and 6000 degree angstrom coincide with each other. Calculate the thickness of the film. So what is given in this problem? Mu refractive index of soap film is 1.33. Then I angle of incidence I is equal to sin inverse 4 upon 5. Lambda 1 is equal to 6100 degree angstrom and lambda 2 is the 6000 degree angstrom, and we have to find thickness. Cos of R is equal to under root 1 minus sin square R is equal to 1 minus sin square I upon mu R is equal to 1 minus 4 upon 5. Sin I is 4 upon 5. 4 upon 5 bracket square upon 1.33 bracket square is equal to 0.7988. Cos of R is 0.7988. For minimum condition 2 mu t cos of R is equal to n lambda. Then for nth dark band of lambda 1 is reflected light, 2 mu t cos of R is equal to n lambda 1. For n plus 1 dark band, then 2 mu t cos of R is equal to n replaced by n plus 1, then n plus 1 lambda by 2. As nth dark band of lambda 1 and n plus 1 dark band of lambda 2 coincide, then n lambda 1 is equal to n1 n plus 1 lambda 2 n lambda 1 is equal to lambda 2 multiply bracket n lambda 2 plus lambda 2. Therefore n is equal to lambda 2 upon lambda 1 minus lambda 1 is equal to lambda 2 is 6000 divided by lambda 1 6100 minus 6000 is equal to 60. Put n is equal to 60 in equation first. Then t is equal to n lambda 1 upon 2 mu t cos of r is equal to n is 60 into lambda 1 6100 multiply 10 raised to minus 8 upon 2 multiply 1.33 into 0.7988. Then thickness of the film is 1.72 into 10 raised to minus 3 centimeter. A glass plate having thickness of 0.4 into 10 raised to minus 4 centimeter is illuminated by a beam of a white light normal to the plate. Mu for glass 1.5. Calculate the wavelength within the limits of visible spectrum. Lambda is visible spectrum wavelengths are 4000 to 7000, which will be intensified in the reflected beam. What are given things? T is equal to 0.4 into 10 raised to minus 3 centimeter, mu is equal to 1.5 and normal incidence R is equal to 0. For maximum reflected system, 2 mu t cos of R is equal to 2n minus 1 lambda upon 2. Rearrange this equation. Lambda is equal to 2 multiply 2 mu t cos of R upon 2n minus 1. For n is equal to 1. 2 into 2, put the value of n, 2 into 2 into what is refractive index 1.5 into t 0.4 into 10 raised to minus 4 into cos of 0 upon 2 into 1 minus 1 n is equal to 1 is equal to 24,000 degree angstrom. For n 2 into 2 only change n is equal to 2, then 8000. For n 4800. For n is equal to 4, 3428. So in the visible spectrum, lambda range is 4000 to 7000. For n is equal to 3, the value is 4800 degree angstrom. So I hope you have understood this. Thank you.